Hello friends, in the series of learning C programming, here I am going to explain the program to check whether given number is prime or not. Now let us see the logic first. See what is prime number exactly, that first you must know, then only you can write a program. Prime number means what? A number which is divisible by 1 and itself only, that is nothing but a prime number. For example, 5, it is a prime number, yes. Okay, why? Because 5 is divisible by only 1 and 5. You cannot divide 5 by any other number, means it is not fully divisible by any other number. Okay, then consider 4. 4 is divisible by 1, 2 and 4. Okay, means you cannot say that this 4 is a prime number. Getting my point? See, 4 is divisible by 1 as well as 2 as well as 4. Means whenever you try to divide 4 by 1, then remainder will be 0. 4 by 2, remainder will be 0. 4 by 4, remainder will be 0. Means 4 is not divisible by only 1 and itself. 5 is divisible by 1 and itself. That's why 5 is a prime number. Okay, but 4 is not a prime number. Here what logic we can apply, because see, we cannot check that the number is divisible by 1 and itself, then we cannot say that a number is prime number, because all numbers are divisible by 1 and itself. Here we have to check that it should not be divisible by any other number rather than 1 and itself. Getting my point? Means here how we can check that? See, if we try to divide that 5 number by 2, then remainder is not 0. 3, then remainder is not 0. By 4, remainder is not 0. Okay, means it is not divisible by 2 to 4. Getting? Means we will try to divide this number by 2. Is it divisible? No. 3, is it divisible? No. Again 4, is it divisible? No. Means now we can say that the number is a prime number. But let us check for 4. We will try to divide that 4 number by 2. Yes, it is divisible. That's why it is not a prime number. Getting? This logic we can apply to check whether given number is prime number or not. Means here in general we can consider like n is a number, suppose. Then we can check whether that number is divisible by 2 to n minus 1. If it is not, then we can definitely say that the number is prime number. Otherwise it is a composite number. Now for 1 there is a special case. 1 is neither prime nor composite. We cannot say anything about that. Okay, that's why from 2 onwards we can check that whether the number is prime or not using this logic. Means we will divide that number by 2 to n minus 1. Here we have to use loop concept. Getting? 2 to n minus 1, we will try to divide that number. And if at any intermediate point it is divisible, then we can say that it is not a prime number. But at any intermediate point it is not divided, then we can definitely say that the number is a prime number. Okay, this logic we will apply in this program. Now let us see the program. Now see, simple, we have to first write comment. Comment is very much important always, that C program to check whether given number is prime or not. Okay, now we have to include header files first. Always compulsory section is a link section. Here we have to include header file. These are file inclusion preprocessor directives. How to write that? Simple, hash include stdio.h. Similarly, hash include conio.h. Okay, now the next point is function. Main function we have to write simple, int main. Now first we will declare one n variable, because we have to accept that number from user, and for that there should be one integer variable, that is let n. Now counter is required because we have to check whether that number is not divisible by 2 to n minus 1 for prime checking. Okay, and that's why one I variable as a counter purpose we will declare. One flag variable is required there. See what is the purpose of this flag, that I am going to explain. But still, I mean, currently at this position, just try to understand that we will require here flag. Okay, initially its value should be 0. Okay, now what is its exact use, that I am going to explain, don't worry, just wait for some time. Now see, first thing is clear screen function you have to use, which is present in conio.h, and that is only for Turbo C editor. If you are using Turbo C editor, then it is required. Otherwise, if you are using any advanced compiler like Dev C++, then it is not needed. Okay, but here I am just considering that you are using Turbo C, and for that we have to use CLR SCR function. This is to clear the output screen. If any output is there on previous output onto the output screen, that should be cleared. Okay, so that you will get fresh output of this new program. Now next is, see, we have to just accept that number from user, and for that first we have to give message to the user, then only user will enter the number. And how to give message to the user? Simple way, use printf. Printf, enter any number. Now after getting this message, user will enter the number. See how I have written printf, then open close parenthesis, inside that in double quotes we have to write the message. Here /n I have used, this is a escape sequence character to go to the new line. It is always better to use /n, means everything should be displayed onto the new line properly. That's why first cursor will be shifted to the new line, and then enter any number, this message will be displayed onto the output screen. Now after that, after getting this message, user will enter a number that we have to catch and we have to store inside n. Okay, now for that we have to use scanf. Scanf. Now n is of type integer, that's why I am using here %d ampersand n. Okay, now user will enter the number that will be scanned and will get stored inside n. Here we have to compulsory pass address of that n, and we have to call it as a ampersand n. Okay, now next thing is, now we have a number, now we have to check whether it is prime or not. Now we will try to divide that number from 2 to n minus 1. Here we are not considering that one number case. Okay, you can check if n is equal to 1, then you can give message to the user like the number is neither prime nor composite. Okay, that part you can write here using if, but here I am not considering that. Just here I will check that whether the number is prime or not. I am considering that number is 2 or greater than 2. Okay, now for that we have to just try to divide that number from 2 to n minus 1. Here I am writing that part. See, here for that we have to use for loop. Loop is compulsory there, because whenever you want to repeat any action in a program, then we use, for repetition we use loop. Okay, now for I equals to, from 2 to n minus 1, means for I equals to 2, I less than n. I less than n means of course up to n minus 1, I plus plus. Now what we have to do? Here we have to check whether that number n is divisible by 2. Yes, no, then 3, no, then 4, then 5, up to n minus 1. Getting? Means we have to check whether n is a number mod I, because I is changing here. See, I is initially 2, then 3, then 4, then 5, up to n minus 1. That's why we have to check whether n mod I equals to 0. If it is equal to 0, means what? It is divisible. Okay, here see what I am writing. If n modulus I is equal to 0. 0 means remainder is 0. Remainder is 0 means that n is divisible by I. If the number is divisible by any intermediate number, means rather than 1 and that number itself, then it is not a prime number. Means here, suppose the number is 4. 4 modulus 2 equal to 0. Yes, now we have to stop. There is no need to go forward. And that's why here see what I am doing. Here that flag variable I am modifying to 1. And now we have to stop also. And that's why here I am placing that break. Getting? Now close this for. That's it. Now see here, suppose the number is 5. 5 divided by 2 means 5 modulus 2 equal to 0. No, it will not execute this part. Then 5 modulus 3, again it will not execute. 5 modulus 4 will not execute and will come out of this loop automatically, because up to 4 it will execute the loop. This loop will be executed from 2 to 4 because the number is 5. Okay, and it will never change the value of flag. Why? Because at any place the condition is not true. At any intermediate place the condition will not be true. If it is 4, then of course the condition will be true at the first point, means whenever I is 2, 4 modulus 2 equal to 0, condition is true, flag will become 1, and break means here we are here. Break means break is used to come out of the loop instantly. Means it is not like that we are coming out of this if, we are coming out of this for. Break is used to come out of the loop instantly, not only from that if. Okay. Now see, whenever we are at this place, then we can check value of flag. If it is 0, then we can definitely say that this has not executed, and that's why flag is 0. Flag is 0, this has not executed means the number is of course prime number. It is not divided at any place. Getting? And that's why here we will write, we can check like this, if flag is equal to 0, means here we can definitely say that the number is prime number. Simple. Here we can display like printf, the number is prime number. Only prime number I am displaying. Else not a prime number. That's it. Printf not a prime number, and stop. Here get ch we can write because I am considering here that Turbo C compiler. Okay, that's it. This is just a program to check whether given number is prime or not. Here what I have done, here I have declared ni and flag. N is to accept a number from user, flag is for that prime number checking. Okay, inside a loop I just want to modify the value of flag if at any intermediate position the number gets divided. Okay, otherwise flag will remain 0. And I is for counter purpose. Simple. Here I have accepted that number from user. Then from 2 to n minus 1 we are checking whether it is divisible by that I. I is changing from 2 to n minus 1. We are checking whether that n number is divisible by I or not. At any intermediate place, if it is divisible, then we can definitely say that the number is not a prime number. And that's why we are not displaying here. We are just modifying the value of flag here. Okay, if flag is 1 and we are coming out of the loop, here we can check whether flag is 0. Flag is 0 means not divided at any place. There we can display the number is prime number. Otherwise simple, not a prime number. Getting? Now just let us see the practical implementation of this program. Here we have used Turbo C editor. We have to just create a new file, new. Now here we have to just start writing program. First thing is we have to just write comment. It is always better to write comment. So then here we will write like this, prime number program. Okay, now we have to include header files here, hash include stdio.h, and the next one is conio.h. Now main function, int main or void main also we can write, no problem, but here we'll write int main. Now to check whether given number is prime or not, first thing is what are the required variables. See, integer variable n I am declaring here to accept the number from user. There should be some space inside a memory, and so that we have declared here one integer variable n. Now next one is, here we have to just declare one flag variable. I counter is needed here. Now next, clr ser, clear screen function we will call to clear the output screen first. To check whether given number is prime or not, first thing is we have to accept that number from user, and for that first the message should get displayed onto the output screen, like enter the number, then only user will enter that number. Okay, and to give message to the user we have to use printf statement, like printf in round bracket in double quotes, first I am writing /n so that cursor will get shifted to the new line, and then the message will get displayed, enter any number. Now close the double quotes, close the parenthesis and give semicolon. Now scanf %d because it is integer, and where to store this number? N, comma n. Ampersand n we have to write because in scanf we have to give address. Okay, now here we will start logic to check whether that given number is prime or not. See, whenever a number is divisible by 1 at itself only, then the number is called as a prime number. That's why we have to check whether that number is not divisible by 2 to n minus 1. If at any intermediate place, suppose is not divisible by any number, then we can say that this number is a prime number. That's why we have to start from 2 to n minus 1. Here I counter we will take I equals to 2. Now we will start from 2 to n minus 1, and for that we will place a loop, and for that we will take one counter. Okay, I equals to 2, I less than n means it will run from 2 to n minus 1. I plus plus, every time I am incrementing counter by 1. Okay, that's why it will just go like 2, 3, 4 up to n minus 1. Now here we will check whether that n is divisible by I, because I is ranging from 2 to n minus 1. We have to check whether that n is divisible by 2, 3, 4, 5 up to n minus 1. If it is not divisible at any intermediate place, then we can definitely say that it is divisible by only 1 and itself. That's why we can say that the number is prime number. Getting? Now here see what I am doing. If n modulus I equal to 0 means it is dividing, means n is divisible by I, then this condition will become true, and in that case number will not be the prime number. That's why we will set flag to 1, and we will stop here the loop execution, and to stop the loop execution instantly at any place we have to use break statement. Now see, whenever this condition will become true, n modulus I equals to 0, whenever this condition is true, that means that number is divisible by I. Remainder is 0 means it is perfectly divisible by I. Okay, means we cannot say that the number is prime number. Suppose the number is 4. 4 is divisible by 2. Yes, then flag will become 1, and we are coming out of the loop, because no need to go forward. At 2, if it is divisible by 2, then of course it is not a prime number, then no need to go forward. If it is not dividing by 2, then go forward, again check for 3, again go forward, again check for 4, and so on up to number minus 1. Getting? Now here at this place, if flag is 1, then we can definitely say that it is divisible by any intermediate number, means from 2 to n minus 1. That's why the number is not a prime number. Here we can check, like if flag is equal to 1 means it is not a prime number. Getting? Otherwise we have to display the number is prime number, means else. Whenever we want to check for any condition, we have to place a if else. Okay, whenever you want to repeat something, then we have to use loop concept. Here else printf it is a prime number. Getting? Here we have used if else. If else, when to use if else? Whenever you want to check for any condition, then we have to use if else, means if that condition is true, then if part will be executed, otherwise else part will get executed. Now next thing, after else, here we have to stop. Now simple get ch we can put for waiting purpose only. This is not required for other compilers. Okay, now let us see. We'll compile this. See, there is one warning. Function should return a value. See, why this warning? Here we have mentioned return type of main as an integer. That's why at the end we have to compulsory return one integer value from this function. That's why we will place here return 0. It is compulsory. Now again compile. Alter F9. No error, no warning. Okay. Now we have to run the program. Enter any number. Let here number is 5. See, 5 is a prime number. It is a prime number. Yes, it is perfectly. Okay, now again we'll check. See, again I am entering one more number. Let 8. 8 is not a prime number. Yes, not a prime number. Getting? Now this is now perfect program for checking prime number. You can write in this way. Let I don't want to use flag here. Then what should be done? That I am going to discuss here. See, I am not taking this flag variable. Then also we can do this program. See, flag I am not taking here. Then here also we cannot do this. Only we will place here break. Okay. See, here we have accepted that number from user. Then I equals to 2 to less than n I plus plus means 1. Whenever I will become n, this loop will get terminated automatically. Okay, otherwise loop will get terminated because of this break statement. There are two possibilities. Okay, either this loop will get terminated because of the for loops termination condition. Like I is n, whenever I will become n, automatically this condition will become false. I less than n. Okay, this condition will become false. Whenever I will become n, this condition will become false. Okay, otherwise this loop will get terminated because of this break statement. Means at any intermediate place, suppose this condition is true, this one, at any intermediate place, suppose this condition is true, then again in that case also loop will get terminated, and at that time the value of I is not n. Value of I may be anything that is in between 2 to n minus 1. Okay, there are two cases. Okay, here we can say that, see, if I is n, means this loop has executed fully. Fully means why? Because break statement never gets executed. Means at any intermediate place, means that number is not divisible by 2 to n minus 1. In that case, the loop will get executed fully. If number is divisible by at any intermediate place, in that case loop will not be executed fully. Means I is not equal to n in that case. If loop gets executed fully and I is n, means that number is not divisible by any middle number, means 2 to n minus 1. In that case we can say that the number is a prime number. Getting? Means in that case I is n. See, if I is not equal to n, means the loop has not executed fully. Getting? Means it is not a prime number. Otherwise we can say that the number is prime number. That's it. Now this is the program how we can check whether given number is prime or not. Now again we will see whether it is working or not. See, alter F9 to compile. No error. Run. Control F9 is we can use to run the program. Now I am just entering 13 number. See, it is a prime number. Yes. Again I will check. Control F9. Suppose the number is 8. Now this is not a prime number. Yes, it is working. Means instead of flag we can also check value of I for checking whether given number is prime or not using this technique. Means if this loop has executed fully, at the end value of I will become n, and in that case this condition will be never true. Okay, that's why value of I will become n. If this condition is true, then at any intermediate point the loop will get terminated. That's why value of I will be less than n always. That's why here we can check that whether I value of I is not equal to n means this loop has terminated at any intermediate point, means this number is not a prime number. Getting? In this way we can do program to check whether given number is prime or not. Now you can take a screenshot of this, see this part, then the remaining part. Getting? Just try it. And if you want to improve your programming skills, always do programs. If you are doing more and more programs, then you automatically your logic will get improved, your programming will get improved. In the next session we will see one more interesting program, one more important program. Till that, take care. Bye bye. Thank you.